Welcome to part 6 of our live training session here with our RB25 Swap 240SX. In our last video, we completed the closed loop boost control tuning process on pump gas. This video, we're going to be taking a look at how to work with the flex fuel based tuning in our model volumetric efficiency style tuning strategy within our Link G4x systems. So we're going to be learning how to integrate fuel tuning, spark timing tuning, as well as boost control tuning based on the flex fuel amount that we have within our fuel system. So based on the ethanol concentration that we have that we're measuring. So we've tuned it now 93 octane. We're going to be putting a higher level of ethanol concentration in our fuel system and then learning how we can bias between the different ratios of blends so that we always have the proper fuel, spark, and boost delivered to the engine under any blend of ethanol. We have a lot to cover. Let's jump into our video so we can check this out. Welcome back to our live training session here with our RB25 Swap 240SX. In our last video, we completed the closed loop boost control routine. We have everything nailed down, we have a boost target we programmed and a boost by gear and RPM specific table, and we were achieving the boost targets that we were programming. We also set up our gear and our speed here very quickly so that we were able to use gear reference in our boost control. Now, we've also dialed in on top of that the fuel and spark timing for those higher boost levels. Everything at this point is nailed down for 93 octane that we're previously running in that last video. This video we're going to be introducing working with a flex fuel based tune going into a modeled multi-fuel type mode. Right now we're just accounting for the model mode, which is the volumetric efficiency, but we're going to move into the model multi-fuel. Now you can do flex fuel control if you have traditional fuel mode. If we look down here under fuel main, we see fuel equation mode, we have it as model. If you're running traditional, you are able to implement a flex fuel based tune. If you're using the 4D tables, you can use your ethanol sensor input and a percentage multiplier and just set up a scale from 0 to 100 in terms of your ethanol content reading. And then you can go in and set it 0 is 0% modifier for fuel, and then 100 is 40% modifier. And depending on where you're at in your ethanol scale, that'll get you sorted out pretty close. And then your spark timing, you can set a 4D spark timing table that would allow you to modify the spark timing against your main spark timing table based on whatever the ethanol content's going to be. So as you go up higher in load, you could add more spark timing. There's a lot of different ways to go about this. In my opinion, the easiest way to go about this is using the model multi-fuel mode, which has allowed us to go in and actually model this for ethanol-based tuning. So I'm going to go in here and switch our fuel strategy over to model multi-fuel. Now when I do this, it's going to say, do you want to clear the air fuel lambda target table 2? Yes, we'll just clear that out. Let's do a store. Now I want to go over a couple things here. First thing, Stoich ratio is set to 14:1 right now. It's set to 14:1 because we're on 10% blended petrol fuels. We have 10% ethanol in our fuel right now here, and that's coming from the gas pump. That's pretty common across the United States. So this represents the Stoich ratio for that 10% blended fuel. And we're dealing with the modeled multi-fuel. This allows us to have a new stoichiometric ratio and having a blending point between the two Stoich ratios. The Stoich ratios are acting as a background multiplier. So if we had 14.7 as the Stoich ratio for pure petrol fuel, it would mean it would have no offset modifier in our fuel calculations. If we're going to 14.1, it means it's adding about 5-6% in the background across idle, part throttle, and wide open throttle. Now, when we're dealing with pure ethanol, or E100, E98, that's going to have a Stoich ratio of 9:1. That's going to be quite a bit of difference between 14.7 and 9:1. It's about a 38-39% difference. So when we're dealing with the model multi-fuel, we establish a new Stoich ratio that allows us to have this background multiplier being applied already, and we should find that our fuel delivery is pretty much sorted out as soon as we get started on dealing with tuning on ethanol-based fuel. Now, we also have some things like our fuel density, and we also have things like our fuel density temperature coefficient. These need to be populated specific for ethanol fuels so we can account for that in the fuel mass modeling. So the fuel mass to injector pulse width needs to account for that and correct it to give a proper injector pulse width conversion. So we have to go in and account for all this. So we turned on the model multi-fuel, which allows us, if we go into display, actually go into layout here and go into flex, we have a flex specific window here. Up here up top, this is our normal injector setup that we would find in that basic setup, but down below is the model multi-fuel that's specific to dealing with this model multi-fuel mode. The injector flow at rated pressure, we want it to match right now what this is showing us. This 2,225, so we're going to type that in. So whatever you ran for your normal
value for your injector flow, you're going to type it in here. Now the fuel density and fuel density temp coefficient, these need to be populated. Now, if I go to help here, go to the contents, we can actually look this up because I never remember this off the top of the head. These are pretty random numbers. So go to fuel density, we'll go to list topics. We can see fuel density, and we can see what Link is going to show us for the value. So fuel type at 20 degrees Celsius, ethanol, and we're going to count for 99% ethanol. We'll say 0.789. So right here, we're going to type in 0.789, enter. Fuel.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.